Welcome to The Explainer. Today we're unpacking a fascinating and honestly absolutely crucial infrastructure mystery. We're going to explore exactly why buying the latest, most advanced green technology is, well, literally only half the battle. And we'll see how this completely shifts the way we need to look at national sustainability goals. Let's get right into it.
So, consider this scenario. The sources paint this picture. Thousands of e-buses purchased and ready to go, but held back by the silent limit of an electric grid that cannot yet bear the weight of the future. Man, that perfectly captures the exact disconnect we're exploring today. It's a massive infrastructural roadblock hiding right in plain sight. And that brings us to the central question of this explainer. Why is the green transition suffocating in its own depots? I mean, it sounds like a total contradiction, right? How can something designed to move us forward be stuck before it even leaves the starting line? Well, stick with me because by the end of this, we're going to have the precise answer, and it's going to completely change how you view our modern cities and waterways.
Here's our agenda for today. We'll start with the electric paradox, then look at the blue transition gap, grid limits and bottlenecks, the risk of stranded assets, and finally wrap up with the strategic roadmap to 2030, plus some final insights.
Section 1. The electric paradox, the illusion of urban progress.
Right now, major Italian cities are experiencing a really dramatic clash between their environmental ambitions and the physical realities of their infrastructure. Thanks to massive PNRR funding, we've seen enormous orders of electric buses. We're talking about Fiamonti, flaming new, completely silent fleets arriving in hubs like Milan, Rome, and Turin. On paper, it looks like an incredible leap forward for zero-emission mobility, but walk through the gates of those historical depots and the reality totally changes. These gorgeous new vehicles are just sitting idle. Why? Because when you try to plug in an entire fleet simultaneously, the local distribution networks, which were designed decades ago for vastly different loads, are suddenly left, as the sources put it, short of breath.
So the crucial point here is what our sources officially term the paradox of the depots. It's essentially procuring green vehicles before securing the energy value chain. See, the bottleneck isn't a lack of political will or money, and it's certainly not a lack of signed contracts. The failure is entirely one of interagency synchronization. Basically, we bought the technology before we built the plug to power it.
Section 2. The blue transition gap, maritime and lacustrine networks.
The contrast we see here provides a really stark benchmark. Up in the Norwegian fjords, zero-emission ferries aren't just some novelty. They're the active operational backbone of regional transit running at full capacity every single day. But down in Italy, despite a massive geographical advantage with all its coastlines and lakes, innovative projects remain stuck as unexpressed potential. They're basically confined to being pioneering experiments rather than actual scalable solutions.
To truly understand this unexpressed potential, we just need to look at a few specific regional deficits. Up in the northern lakes, like Garda, Iseo, Maggiore, the transition is totally trapped because they lack permanent electrified docks. Down in the Venice Lagoon in the minor islands, despite introducing hybrid units, they are completely missing the capillary, high-power charging stations needed at terminal nodes. That's essential to sustain high-frequency shuttle services like the ones to Piazza San Marco. And in Syracuse and Ortigia, they desperately need light electric ferries to bypass that nightmare summer traffic and kilometer-long queues on the mainland. But without equipped piers and electrified docks, well, that brilliant solution remains confined to paper.
Section 3. Grid limits and bottlenecks, uncovering the hidden iceberg.
So at the base of this hidden iceberg are the silent limits. This is the fundamental inability of a legacy electrical distribution network to handle the simultaneous, high-density charging loads required by modern electric fleets. In plain English, this means the primary electrical cabins just don't have the capacity. And even if they did, without revising the official power commitment levels, the grid legally and technically cannot deliver the energy these new ferries and buses actually demand.
This clash between ambition and reality is pretty incredible. Just notice the regulatory speed here. On one hand, we have rapid, high-speed procurement of green technology driven by PNR targets. But then, that high-speed tech slams right into infrastructural realities. Building permits for the necessary grid upgrades move at what the sources call passo d'uomo, literally a walking pace. It turns out you can buy a futuristic ferry in a few months, but getting the permit to plug the thing in, that takes a bureaucratic eternity.
Section 4. Risk of stranded assets. Gardens of metal.
Now, failing to synchronize our grid upgrades with vessel deliveries creates a massive financial risk. Without adequate charging infrastructure, these massive capital investments become completely economically unviable. Think about it. Electric propulsion only provides a return on investment if it can operate at a daily, high-frequency service level. If vessels can't charge fast enough, they can't run. And we risk turning our shiny green fleets into expensive, immobile metal gardens. The sources emphasize that adapting minor ports, or portualidad minore, is the absolute linchpin to preventing this and saving the national strategy.
To summarize the core warning from the research here, without dedicated infrastructure, a potential transit revolution transforms into a series of localized curiosities. Without the permanent, high-tech, electrified dock, the electric boat is really just a fleeting experiment. It simply cannot scale.
Section 5. Strategic Roadmap to 2030, a Blue Plan for Italy.
A modern pier can no longer just be a piece of wood or concrete you tie a rope to. It really has to be a technical symphony, a high-tech energy hub. Port authorities need to follow a strict checklist. They have to upgrade primary cabins specifically for simultaneous demand so the grid doesn't just crash when a whole fleet plugs in. They must install high-power rapid charging, align power commitments with peak operational needs, and honestly, most critically, streamline that walking pace permitting process to actually match the speed of modern innovation.
To actually execute this by 2030, the roadmap lays out 3 mandatory steps for stakeholders. Step 1, establish mandatory interagency synchronization protocols. This means grid managers must be sitting at the table the exact moment a vessel procurement contract is signed, not years later. Step 2, accelerate infrastructure construction well past that bureaucratic walking pace. And Step 3, ensure simultaneous demand readiness. We absolutely have to build infrastructure that anticipates the maximum load of the future, which prevents these breathless networks we're seeing today.
Section 6. Insights and thank you. Looking to the future. I want to leave you with this final, really provocative thought directly from the source material. To build a sustainable blue economy, we must match the speed of dreams with the technical realities required to support the weight of tomorrow. Understanding this invisible infrastructure makes us all so much better informed about what true sustainability actually requires. It's not just about buying the shiny new vehicle, right? It's about having the vision to build the foundation beneath it. Thank you so much for joining me for this explainer. I really hope you found these insights as fascinating and useful as I did. Keep learning and keep looking beneath the surface.